Welcome to Introduction to Programming. This is Chemical Engineering 263. We're going to go through some Python and Excel examples. I'm John Hedengren, and we're going to be covering today not the Excel. We've already done this in some prior videos. We're going to show how to do the equivalent solutions in Python and go through an introductory programming exercise with Python. You can come to this address right here, APMonitor.com/CHE263 for all of the content. And if you just scroll over on the right, you can see the schedule. And here you can see the different topics. And we're going to cover Excel and Python together. So when you click on this homework assignment, you're going to do it in Excel and Python. Now if you want to use Python, you can use this Google Colab. It'll open up the sheet. You don't have to install anything. Or you can come to a link where I can show you how to install Python on your local computer. So if you're just getting started and you want to try out Python, I'd recommend Colab. Otherwise, go and install it yourself on your own computer. Okay, so what I'm going to do now is just go through this very first one. I have it open up in Jupyter Notebook. But if you need some help installing IDLE and script processing, I'd install this one from python.org. That's for Python 3.7. And then here is Anaconda as well. Okay, so the second video is how to install Anaconda with Jupyter Notebook and also Spider as a nice integrated development environment. Okay, so let's go ahead and just get started with this. We're just going to run through a couple of exercises on this, and the very first one is just print a message. Okay, so I'm going to print hello world, and then if you want to run this, you can hit Control Enter, and then it will run that. It'll show a little number off to the side, and that says in 7, so that's the order at which these have run. Okay, so this one is run in order. That was the 5th one, that cell that ran. And here's the 7th. And then you can insert cells as well. You can go insert below. And let's say I just wanted to print something else. Okay, and Python is wonderful. Okay, and there I've printed something else. So you can manage your cells. If you want to delete something, you can come here and delete the cell, and then it disappears. Okay, and if you want to run all of them, you can come into kernel, and you can go restart and run all, and it restarts your kernel, and then runs all of the cells that it can, and there may be some errors in here that we have to work through. Okay, so there's the very first one. The next action that we want to do is go to this and show help for some of our functions. So if you're confused about what a function does, you can type help, and for example max. Then that will bring up the max function, and it shows you how to use it. Okay, and what I'm going to do now is replace this with, I'll just replace this with max of 5,2, and then it shows that the maximum is 5. Okay, now we can also do an F-formatted string. So I'll say the max of 5 and 2 is, and then I can put this in these curly brackets. Okay, and let me just end this. Okay, and then it will print it out. This is new in Python 3.6, this formatted string, and then you put the thing that you want to replace, the number right here. You can also do this another way. You can say the max of 5 and 2 is, and then you can add a string and do max 5,2. And that'll produce the same thing. So in this case, I've just added 2 strings together, concatenated them. This is a formatted string. Okay, so there I've printed those. Here's how you get, you also reviewed how to get help on functions. Let's go down to the next one, how to show how to declare variable names. So this variable names are going to be important to be able to carry values over from one line to the next, or be able to pass values into functions. or for other reasons as well. There are three basic types of variables. You have strings, integers, and float variables. And so strings are going to be things that are encased in single quotes or double quotes. Doesn't matter which one you use. And then integer, like 2, 4, -1. And float will have a decimal point. Okay, so let's go ahead and correct the errors with this. We can't start with a number. Okay, and then next it's going to show an error. Here's some invalid syntax. It'll show that it's on this line. Okay, it says line 3, so 1, 2, 3. And so you can't have spaces in your variable names. Okay, here's the next error. We can't have some of these special characters. Okay, and then this one is a comment character. So I want to uncomment that. And there I have my different variables. So I could print those. For example, there's my var equals 4. And so I reassigned that. It was originally equal to 2, and I said equal to 4, and so it's going to print a value of 4. Okay, so there's variables and how you name them. Okay, variable types, and sometimes we want to be able to know what is the type of a variable, so we can just do type myvar. And that's going to be equal to class int. It's going to be an integer type. So you can see it's going to be int, float, or string. And so let's go ahead and just go down to this next exercise and walk through this one right here. We're going to just print the values of these. And so now I'm going to, I'll just print, and let's do our formatted string. Okay, we'll say x equals, and they'll put x in there, and then y equals y, and let's do z equals z. Okay, it looks like it gives me 2 when I do that sometimes. Okay, let's go ahead and just look and see what that is. Okay, there's x, y, and z. Okay, now let's go ahead and determine the types of each of these. And then I can just do type x, for example. There's my integer, and I can do y and z. Okay, so you can always look and see what the type is. So for example, if I had a new one, and we'll cover lists later, but let's say I had 1, 2, 3 as a list, and then I went print type w. Okay, and you can see that one is going to be a list. Okay, so there's going to be other types of variables that we're going to use as well: tuples, lists, dictionaries, and others. But the basic ones are going to be integer, string, and float. Okay, so let's explain why x is equal to 46. So if you notice that, x is equal to 46 and not equal to 10. Because here I had 2 plus 3. And normally that would be equal to 5 if you were adding integers together. But in this case it equals 23 because I'm adding 2 strings together. So that equals this 2 plus 3 is going to be equal to 23 instead. Okay, and so if I just put that at the end, I kind of break this apart. Okay, there's 23. And then if I convert it into an integer, then it's going to change it from a string with the 2 quotes around it to something that's an integer, and then I can multiply it by 2 and get 46. So the reason why it's 46 and not 10 is because we're adding 2 strings together instead of 2 integers together inside here, and then we convert it to an integer and then multiply it by 2. Okay, so let's go on to the next one now. Functions. Functions are very important because we're going to use some that are built in, or we can define our own as well. We'll cover how to define our own. So let's just go ahead and put in here your name, replace this. I'll just say Python student, and then we can use one of the functions of this. So we have like maybe dot value. Okay, let's just see what, I don't remember what all the different properties of this are. So let's just look at all the different properties of my string that we can use. Okay, so we have length, we have a lot of different functions that we can use with this string as well. Okay, but let's just do one mystr lower. Okay, then it converts that string to lowercase, so it takes all of these. Okay, it's just going to do the P and the S right at the beginning there and convert it to lowercase. So you can always look and see what are all of the, you can do dir, and then you can do your object, and you can see all of the different functions and properties that it has. Okay, let's go on to operators now. So this is the precedence order for the operators. The exponent's going to be processed first, then we're going to have the multiplication and division, then addition and subtraction, then we're going to do comparisons, and so forth. Okay, so here are the different operators. So now we want to determine in this one, use this operator list to determine whether 5 to the 5th is greater than 2 to the 10th. So we're going to use the exponent there. We're not going to use a caret sign like this. We're going to use instead 5 to the 5th. Okay, and we're going to see if that is greater than or equal to 2 to the 10th. Okay, so that says it's equal to true. So this is yet another variable type. It's called a boolean. Okay, so my boolean equals, okay, and then if I do my boolean and run it again, it says it's true. And if I just do a type on this, okay, it says it's a boolean. That means it's going to be either true or false. So there's our condition right here, 5 to the 5th greater than 2 to the 10th, and it said that that was true. Okay, so you could also print out the numbers yourself. Okay, and you could compare them yourself, or you could use the greater than or equal to operator to determine, and that will return true or false. Okay, we'll use that for conditional statements later. All of these conditional statements and comparisons, we'll use those to determine the flow of the program. So if certain conditions are met, we're going to do certain actions, and if other conditions are going to be met, we'll do other actions. Okay, let's go down to problem number 2. So all of this was just basic introduction to programming, and let's do something that's a little bit more engineering centered here. We have the rate of heat transfer from a flat plate, okay, is going to be cooled, okay, with a cooling fluid. Okay, so here's our plate that we have, and fluid is going to be flowing over this plate. And we have a couple expressions here. The heat that's going to be transferred away from this plate, okay, that's going to be equal to Q equals the heat transfer coefficient times the temperature of the plate minus the temperature of the water. Okay, and we want to try to find this heat transfer coefficient right there because we know the two temperatures, and then that will help us find the heat loss. So the thing that we're going to need to use in this is calculate a Nusselt number. Okay, we're going to calculate this dimensionless number and U, and that is going to be equal to H times L divided by K, and then we'll just rearrange this to solve for H. Okay, and then plug that up into the expression right above it. So we have the Nusselt number is going to be a function of the Reynolds number and the Prandtl number. So you can see a little bit more about this here, and there's just some constants that you'll need to put in and do this calculation. So I also put the solution here just so you can know what the answer should be. So it's complicated enough. There's enough numbers here that you know, it's easy to get tripped up at some point. And so I just put some of the answer there as well. Okay, so let's go down to Okay, so we have some of the constants that are listed there. We want to fill in some of these constants right here that I took out. So here's the mu value. That's going to be 9.79. And if I want to do times 10 to the minus 4th, I can do times 10 to the minus 4th. Or the shorthand way of doing this is e minus 4. Okay, this is a scientific notation. And then I want to fill in this one as well for the k value. And so if we just go up, that's going to be equal to 0.601. And all of these are going to be in SI units, so we don't need to use any unit conversion. Okay, let's do the Reynolds number now. The Reynolds number is going to be equal to the density, the rho, times the length, times the velocity, divided by the mu value. And the Prandtl number, okay, let's go to, let me scroll down here a little bit. Okay, Prandtl number is next, and again that's just going to be, that was given to us right here, the mu CCP over k. And so let's just plug those in, mu times CCP divided by k. And then let's go with Nusselt number now. We have our Reynolds number and our Prandtl number. And so this one's just going to be a little bit more complicated, 0.332. And it's right here. And multiplied by the Prandtl number. And then to the 1 divided by 3. I always like to put the decimal points there. Earlier versions of Python had integer division, so that would be 1 divided by 3. If you were dividing integers, it would be equal to 0. It causes all sorts of problems. Okay, so I just avoid that by always using floating point numbers there. And then Reynolds number to the 1 divided by 2. Okay, and just check that, make sure I don't have any errors. Okay, here's the next one. Our h value. So I'm just going to rearrange this one over here, and I'll know that h is going to be equal to Nusselt number. Let's see if I can get this to right. Okay, Nusselt number times k divided by L. Okay, so let's go ahead and compute that one. Just algebraically rearranged it. And so that is nu times k divided by L. And let's finally do our Q value. Okay, it's going to be H times temperature of the plate minus temperature of the water. Okay, so there's my answer, and I just printed this. Let me just show you. You could just do print Q, for example. But I just rounded it off. Okay, I just did round to 2 decimal places. And then I just, you could also do your formatted string as well. Okay, formatted string. And then we could say, put this in curly brackets. And then do watts per meter squared. Okay, that'll give you the same thing as below. Okay, so there's our answer for the amount of heat that's transferred away from this plate. Given some of these constants, we saw a scientific notation. We did some basic calculations with some of the operators, including the exponential, multiplication, and division, and then did a formatted string print. Okay, let's go on to the problem number 3. There's many different packages that makes Python very useful. Here are some of them. If you'd like to open up some of these links, here's Numpy, for example, Matplotlib, SciPy, Pandas, Gecko, TCLab. These are a couple that we've produced. And there's many built-in packages, but if you need to add packages or remove them, this shows you how to do that with pip install or conda install. And you can manage your packages. So you can add or remove some that you like, and if you do pip install, for example, PySerial or Gecko, it will go out and get the latest version of that and install it for you automatically. Okay, so there's how we get the packages, and then we can import them. We can do import NumPy, and then we can use functions within NumPy. So for example, if I want to do help numpy.linspace, okay, there it is. Or I can do import NumPy as np, and then that shortens it, so I don't have to use NumPy all the time. I can just do np.linspace. Okay, the way that's not recommended is to do from NumPy import all, and then you could do something like help linspace. You can leave off the NumPy np dot, but this is not recommended because then it clutters up your namespace. There might be conflicts with other packages. So the recommended way of doing this is import NumPy as np, and then you can use the functions. Okay, so there's help on numpy.linspace. Okay, equally spaced values between start and stop. Default is 50 values. Okay, so let's go ahead and create 20 equally spaced values between 0 and 2 pi. So on this one, we're going to use one of the built-in constants, np.pi. And so I'll just do x equals np.linspace. Alright, and then inside there I'll do 0 to 2 times np.pi. And then we'll have 20 values. If you leave that out, then it'll do 50 values. So let's just print x. Okay, there are 50 values, but if you want to just limit it to 20, or you wanted to do just 5 values, you could do however many you want. Okay, so there's 20 values. Okay, now we want to calculate the sign of x, and so now I'm just going to do y equals 2 times np sign of x divided by 2, and when I do that, then if I print y, I can see all of my y values. Now we want to be able to, it's nice to be able to look at the numbers, but maybe we want to be able to show them on a plot. So let's use another package. We're going to import matplotlib.pyplot as plt. This is a very long name, so I'd recommend shortening it down. The conventional way is to do plt. And then the other thing that you'll need to do just for Jupyter notebooks is matplotlib inline. So that'll make your figures be able to show within the notebook. And then we're going to get some help on plt.plot. Okay, so that will show us some help on how we can plot something. Shows us x and y. So let's go ahead and try that. For this one, we're going to create a plot of x and y. And there's our sign for this 0 to 2 pi. And let's add some labels to it as well. Okay, we'll do an x label, and let's do time for that one, and y label, or I could do something like x and then do y. Okay, so I just put in an x and a y there for the two. And you can also annotate it with other things as well. You could do title. Okay, y equals sign of x. Okay, and that'll put it right here with a nice title. You can also give this a label, and let's just say that this is y equals sign of x, and then you just have to show your legend, and then it shows legend, especially if you had multiple values. Let's say something like z equals np cosine of x, and then we wanted to plot that one as well. And let's do another label here, and then this would be z equals cosine of x. Okay, and that would show the z as with the cosine of x in addition to the y. And this isn't sine of x, it's going to be 2 times. I guess I should have put here 2 times sine x divided by 2. Okay, and I'll just change this now to something like trig functions instead. Okay, so there's our plot, just some basics on how to create a plot. You just do plt.plot and then do your x and y, and then you can make it, put labels on there. You can also change the color of the line or the style. So if I do a red dashed line instead, or if I wanted to do a blue solid line, okay, I can do it like that. Okay, and just there's more help if you do the help on that function. Okay, so let's go down to the more challenging one now. This was kind of a warm-up just to show some of the packages, and to get us started we have the tank pressure limits. We're tasked with finding the pressure limits for this vessel, and we can't have any oxygen in there, so what we're going to do is we're going to fill this tank. Okay, we're going to fill this tank with nitrogen at 1.25 atmospheres of nitrogen, and then we'll fill the tank with the liquid, and we want to keep this above 1 atmosphere, so the pressure, so we don't have oxygen leaking in to the tank. So we want to keep it greater than atmospheric pressure, but not greater than 2.5 atmospheres. So our limits are between 1 atmosphere and 2.5 atmospheres. Okay, that's our range, and we're initially going to have 1.25, and what we're going to do is the tank has a capacity of 4,000 liters. Okay, and we're going to operate the tank between 3,000 liters to 3,500. Alright, and when we initially fill the tank, we're going to fill it so that 25% of it is left. Then we're going to fill it up to 3,000 liters, and the overhead space is going to be nitrogen. Okay, so this overhead space is going to be nitrogen, and so we want to know how many moles we have in there initially, and then what are the range of the volume, and also so we're gonna look at the volume and also the temperatures that allow us to stay within the limits of 1 to 2.5 atmospheres. So let's just go down and get started with some of the steps on this. There's a bunch of text here. Also there's the Excel problem if you'd like to go through that. You can also see the problem solving strategy with that one. Okay, so we want to calculate how many moles are going to be in the tank initially, so we're just going to use the ideal gas law, which is going to be PV equals nRT. Okay, so we have P times volume equals number of moles times universal gas constant times the temperature. So if we want to find the number of moles, then that's just going to be equal to the pressure times the volume divided by the ideal gas constant times the temperature. So we're just going to do that initially, even before we put any liquid in there. So we have the 4,000 liters, and so let's just fill that in with P times V divided by RG and divided by T. Okay, and then we might want to print that, print the number of moles. Okay, there we have that one. Then we're going to fill it up to 3,000 liters and bleed off any of the excess nitrogen that goes above 1.25 atmospheres. So we're just going to take the same number of moles that we started with and just multiply that by 0.25. So there's the 25% remaining in that tank. Now we're going to use linspace to create 20 linearly spaced values for volumes. Okay, so this is going to be the volume of our gas. It's going to be between 500 and 1,000 liters. So the liquid is going to go between 3,000 and 3,500. So that's going to leave these 500 to 1,000 for the gas. And then the temperature is going to go between 100 and 600 Kelvin. Hopefully we wouldn't operate outside that window, but we're just going to go ahead and plot that just in case we have some very hot fluid or something like that that enters the tank, or very cold fluid. Okay, so these are our values, and we can just print those if we wanted to, just to look at the volume or the temperature. You can see the 20 equally spaced values between 500 and 1,000. Okay, now the next part is going to be to create a mesh grid. You don't necessarily need to modify this line at all, but if you want to look at what it created, you know, you can say print VM. This one's going to be a 20 by 20 matrix. It's going to be very large. So you can see those are all the combinations of VM that we need, as well as TM. So just leave this one alone. This one's a mesh grid. You can use, you can look at NP, you can do the help on it, help NP mesh grid if you like to look at it, but go ahead and just leave that line alone. Okay, then we have the pressure. We want to calculate, this one's going to be the pressure, all of those combinations of volume and temperature. And so we're just going to calculate PM, and I just put M on there for the mesh grid values. And so we have our 25% of the original volume of the moles. And then we have our TM, and this one's going to be VM. Okay, so there's our pressure at all of those different temperatures and volumes. Okay, now what we want to do is just go ahead and run this one. Okay, we have this Matplotlib. Okay, we need to fill in some of these on the X label and the Y label. Okay, so let's go ahead and just fill these in. Okay, our X label, we need to identify what we're plotting on the X-axis. If we look at the contour here, that's going to be the volume. The Y-axis is going to be the temperature. And then we have the pressure. Okay, so this one's going to be the volume of gas in liters. And then we also have the temperature in Kelvin. Okay, so it's going to create this contour plot for us. So if you come down here, you can see your volume of gas. So as you go to 1,000, there's where the tank is at 3,000 liters of liquid, and there it is when it's at 500 liters, 3,500 liters of liquid. So it's compressed the gas. And then here is the temperature. So you can see these are our limits, the 2.5 to 1. And so we can operate anywhere within this boundary right here. So that's our permissible levels to stay within 2.5 to 1 atmosphere on the pressure. Okay, so you probably didn't catch a lot of this on the plot. Don't worry about that too much. We're going to cover plotting a little bit more in detail. What we wanted to show with this one is that you can use some of the functions like Numpy linspace. You can Numpy mesh grid. Okay, there's a lot of functions that are available in Numpy. And then when you get to Matplotlib, there are things like contour plots, regular plots. You can add labels to your plots, make them more explainable, so easier to visualize and know what's going on with your plots. Okay, so that's it for this tutorial. This is an introduction to Python. I'm going to show you the schedule and just where we're going next. If you come to the course website and you go to schedule, here are the next 6 assignments. So we're going to do each of these in Excel and also Python. And if you're feeling really stuck with this, just come over here to homework help, and there it will show you solution videos for the Excel. I'll also post this one for Python as well.